This video is going to review a couple concepts that we learned in chemistry that will help you be able to predict what elements will react with other elements in the periodic table and in what proportion. Recall the periodic table. You have columns, which we refer to as groups or families, and rows, which are called periods. And we talked a lot about the octet rule. The octet rule states that all elements want a full outer or valence shell. And so we learned that the first row or period corresponds to the first shell, and it can have a maximum of 2 electrons. The second, third, and fourth rows are the second, third, and fourth valence shells, and they can all have 8 electrons. This means that this little guy here, hydrogen, and we draw our Lewis dot structures. We call the Lewis dot structure. It simply involves the symbol and the outer shell electron. This little guy, hydrogen, has 1 electron. Helium has 2 electrons, and that fills the first valence shell. So the first row is absolutely filled. When we get down to the second row, lithium also has only 1 electron in its valence shell. But if we look over here at neon, neon's in the second row, so the second valence shell can have a maximum of 8. And so what the octet rule tells us is all elements either want 2 or 8 electrons in their outer shell. So they're all trying to get this way. A chemical reaction involves the exchange of valence shell electrons. An atom can either 1, give them up, 2, take them, or 3, share them. So a good starting point is to look at carbon. Carbon has 4 electrons in its valence shell. And what's interesting about carbon is it doesn't have the ability to easily lose any of these electrons, nor is its nucleus strong enough to take electrons. So carbon tends to do this. It tends to share electrons with other atoms. So when carbon reacts, say, with hydrogen, this bonding pair of electrons forming, which now both of these electrons count towards the valence shell of both atoms. Carbon reacts with 4 of these. You now have 1, 2, 3, 4, 5, 6, 7, 8 valence shell electrons surrounding the carbon nucleus. It is now happy, and each hydrogen has 2. So hydrogens are now happy. And this follows the octet rule. Carbon has a combining capacity of 4 because it can form 4 bonding pairs. Now, what do we say about sodium? Sodium's Lewis dot diagram is this. If carbon has a combining capacity of 4, Cc equals 4, what is it? What is the Cc for sodium? And the answer is 1. Sodium will lose its 1 electron. This is the Lewis dot for fluorine. Fluorine has 7 electrons in its valence shell. What is its combining capacity? Well, the answer is not 7. It's 1. And this is because in a reaction between sodium metal and fluorine gas, where sodium will give up its electron to fluorine to produce fluoride, fluorine can form one bonding pair, not two or not three. Now this is an ionic bond, and of course they don't share the electrons. The electron is given all the way over to fluorine, but it's still a reaction with only one other element. What do you think it is for nitrogen? Nitrogen has 5. Is the CC 5? No. CC is 3. And again, this is because when nitrogen reacts, it needs to fill 3 spots. So it can react with, say, 3 hydrogens. NH3, which it now has 8 electrons in its valence shell, and all the hydrogens have 2, and everybody's happy. Nitrogen can form 3 bonding pairs. Now you try magnesium, aluminium, and sulfur. What are their combining capacities? And if you have any questions, ask me tomorrow in class. Thank you very much.